Hi, I'm Mike Myers. Tonight's Tuesday night. That means it's time for Let's Make It. This week we're going to show you how to control a servo using an Arduino. Coming up. Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello, welcome to episode number 12 of Let's Make It. This week we're going to work on servos. Going to show you how servos work, explain them a little bit. You're going to probably learn some new terms in this process as well. I'm going to teach a little bit about pulse width modulation and also pulse position modulation. Servos work, I think, in the combination of both of those, the way that I interpret that. Some people say they're PWM and some say they're PPM, but we're going to talk about both of those different technologies. And going to show you how to get a servo to work. And it's actually very simple on the Arduino that comes built in with a library from the Arduino manufacturers that can control a servo right off the bat. You don't have to worry about how to even make the PPM or PWM, whichever one you think it is, work. But we'll explain a little bit how the servo works as well. Like I said, this is episode number 11, and I've gotten more emails this past week, and I love this. Bob Powell and I have gone back and forth a couple times on email this week, like I mentioned him last week, and Dennis Englingler also. I talked to him this week, and I've also talked to Terry Dark. I got an email from Terry Dark. Now, I haven't responded to Terry yet. That's going to be my task for tonight. But it's actually been, the community is growing. I like seeing more people in the chat room. Right now, there is nobody in the chat room except for me. But I like to see people here, but I like to get the word spread around. So if you know people that are like playing with Arduinos and want to learn the Arduino or be interested in this, please spread the word around. We'd definitely love to get this show to grow. It's growing really good, but I'd like to keep growing and growing a little better and make it more of a community. Get people in the chat room, ask questions as I go through this, to try to make it more interactive. All right, so let's hop over to what we're going to talk about tonight. And this is actually a fairly quick night, I think. I always say that though, and it never ends up being that way. So let's go take a look at the Arduino setup that I have. Whoops. All right, so here's the Arduino, and it's a very simple setup this week. You have just an Arduino Leonardo right here, and then we have this servo. This is from Parallax. You can see it says Parallax right there on it. But any servo from any model, airplane or whatever, would work just fine for this. They all work pretty much exactly the same. 3 wires from the servo. You have your 5 volts, which is the red wire. You have the ground, which is the green wire, and then the white is the signal. So let's talk a little bit how a servo actually works. And I used to have one of these torn apart, but I couldn't find it to bring in and show you. But basically all a servo is inside the servo there is a motor, and a control board and a sensor. And the sensor is not much more than a potentiometer, for lack of a better description of it. It basically tells the control board inside of the servo where this dial is in its rotation. And if you can hear that or not, because I'm pushing on it, it's fighting back. I can't see if you can hear this. I kind of hear it, but I don't know if you can hear it or not. But anyways, it's fighting back because I'm trying to make it move, and it keeps saying, that's not where I belong, and it keeps pushing back on me. So it's actually probably not good for it to fight like that. But it's constantly monitoring its position, and you tell it where you want it to be, and it's typically in degrees. This one, I thought it went 0 to 180 degrees, but it appears to be 0 to 175 degrees. At 80 degrees, it keeps fighting. Like it fights me when I move it. It keeps doing that to me. So I've actually backed it off to set 175. And in my program, you'll see that I don't check for that, but that was probably a good thing to add to your program. The manufacturer will tell you what the limit is on it, and that's a good thing to know. So it's not that complicated of a device, and you can get these in many different sizes. I've seen them big enough to control cars, and it works on the same principle. You have a motor with gears that turns this, and a sensor that reads where it is and turns it left or right or clockwise, counterclockwise to get to the position where you told it needs to be. It knows which way to go. And they're typically geared, so the motor spins, not just the 180 degrees. The motor spins many times in a gear. That's why it's so hard for me to push it, because it's all geared down or up. So the first thing I want to do is I want to show you a program. So let me hop over here. I'm going to go to the computer. Well, I'm trying to go to the computer. Not everything's working tonight. Okay, so now I'm on the computer, and this is the sketch that comes by default with the Arduino. So it's very easy. You can come to File, and you can go to Examples, and you can come down here to Servo, and this is the sweep. And I'm going to show you the sweep of the servo. I'm going to walk through the program and show you what it does. It's very easy to do. I'm not going to let this run for very long, and you'll quickly find out why I'm going to not let this run for very long. So I'm going to go ahead and upload it, and you're probably going to hear in the background when it's uploaded. Now, I'm not sure if you can hear it. You can hear it if I talk, because the gate opens on the microphone. But let's go back over to the Arduino. And what you see the servo doing is sweeping back and forth. So it's basically going 0 to 180. Now, I probably should have changed the program not to be 180, because I know 180 definitely causes it to act kind of weird. 176 seemed to be about where it actually stopped acting weird. So it doesn't. I made it 175 as my safe spot. But all it's doing is just basically saying it's going from 0 to 180 degrees back and forth, and it's going to keep doing that. So let's go take a look at the actual program. I'm trying to go to the actual program. Things aren't cooperating with me tonight. There we are. All right, so at the very top, you can say this is default, so you don't see my comments in here, and you can get this very easy. Again, go to File, Examples, go to Servo, and then Sweep. That's what I'm running right now. And the first thing you gotta do is you have to include servo.h. This is the library that includes all the definitions that you need for the classes. And then we come down and we create a new class, or it's called, we're gonna call it my servo, and we're creating the class of servo. So we now have a variable called my servo, and it will function like a servo. And if you can hear in the background that annoying noise, that is the thing still going. So it'll keep going forever. We then are defining a variable called position, and this is where we're going to change. And we're going to change this to where we want the servo to point to, and it's going to be transmitted to the servo to tell it where to go. So in our setup routine, the only thing we have to do is tell this class, the myServo class, where the servo is attached to. Now, I was reading earlier, I don't remember seeing the Leonardo, but typically it's either 6 or 8 servos at a time can be controlled by an Arduino, and the Adruino Mega can do like 24 servos at a time. So it really depends on how many servos you want to do. We're only using one. I only have one working one. I have one that was torn apart when it got broke, just to show people how it worked and what to do with it. All right, so now we're coming down to the loop, and we've gone through 4 loops before, or have we? I don't remember if we did. That's something that one of the emails I got this week suggested that I go through some different language type things, which may be a good idea for 1 week. We don't actually make anything, we'll just show you how it works. But anyways, here's the 2 for loops, and we're going to start at 0, so we're going to say position equals 0, and while position is less than 180, we are going to loop, and each loop we're going to add 1 to the position. So we start out at 0, we're going to tell my servo right, position 0, and we're going to wait 15 milliseconds just to let the servo kind of catch up. And this could be a bigger value depending on how far the jump is you're going to do. In this case, they're figuring 15 milliseconds is enough to go 1 step, or at least have the servo get moving to that 1 step. And we're going to loop through here 180 times. And each time we're going to give it a new position, which is going to go up by 1 until we get to 180. And then when we do that, we're going to reverse this. We're going to say we're going to start at 180, and while we're still greater than or equal to 1, we're going to loop the servo position, and each time we loop, we're going to subtract 1 from the position. So we're going to keep doing that until we get down to 0. And then we're going to go back and we're going to do this all over again. So that's what you're seeing the servo do. That's all there is to this little program. It all fits basically on one screen. And all it does is have that servo go back and forth just like it is right now. You see it's still sitting here doing this. And I hear this more here. I hear it through the microphone. I'm not sure if you're hearing it through the microphone. I'm assuming you are because I hear it in my ears. But that's all this little program does. So now what I'm going to do is I'm going to load another program that I wrote for tonight's example. We can tell the servo what to do. So let me go ahead and I'm going to upload that sketch. And it got quiet all of a sudden because it's uploading. All right, it's uploaded. So let me bring up my serial monitor. I'm going to leave the servo on the screen. And it starts out at position 0. Let's say I want it to go to position number 50. All right, that's position number 50. Let's say I want it to go to position 120. That's position 120. I want to go back to 5 now. So here's position 5. And now I'm going to go back to position 0. It's going to move very little, but it will move. Very little. So what I'm going to walk through now is the sketch that does this. And all I'm doing is taking input from the serial port and positioning it anywhere that I tell it to go. So let's go look at the computer real quick and I'll show you what's going on there. All right, so here you see the serial and you're probably going to hear this in the background, but let's say I want to take it back up to 120 again. You hear it move, it went back up to 120. I'm going to put it back to, let's say, 12, some odd number. And you see it go back to 12. And now we're going to go back to 0, which you're going to hear, but it's going to get really short. Yep, a little short. So let's walk through the program that's doing this. So this allows us to control where we want the servo to go based on, instead of just going 100 or back and forth 180 degrees. Now I'm going to do is I'm going to set the 180 and let you listen to this if you can hear it. Now if you can hear it, it's going to buzzing. Can you hear that? Yeah, you can hear it a little bit. And it's shaking, it's vibrating. It's because it can't really get to 180. So I'm going to go back to 176, which was where it seems to stop. It's no longer buzzing. So 176 is my, for some reason this servo does not do 180 degrees. And I don't have the documentation to say, it may have told me that 175 is the maximum it can do. I don't know. But I'm going to go ahead and put it back to 0. Oops, 0. And there's back to 0. Now there's one thing you're going to notice when I do this is I'm putting a space after each number I do. So if I put in like 11, for example, I put a space. It wouldn't have to be a space. Let's say I go back to 120. It could be any character other than a number. And I will show you in a little bit why that is. It's just the way the serial input worked, and it was the quickest way I could get it to work. Because when you press enter to do a send, it doesn't send a character turn along with it. So I couldn't look for a character turn. So I basically look for something that's a naughty number. And when I see that, that's when I assume the number stops. So if you just put in a number like this, it doesn't see that character, it just sees a number come in. So I had to put in like, so I put in like 20. It's gonna go. It's already at 120. Let's say 19. We're gonna go to 19, and I put a space, and you'll see it comes up and says 19 because it didn't see a character after the 1. We'll walk through that in the code though here, and we'll show it to you. So let's go ahead and close down the serial port. And we see up top just my comments about it. And we come down and we see servo.h, which includes the header. I took the example that was in the example library and added to that, basically is what I'm doing. So I created a servo object called myServo, just like in the example. Then I define a string variable, which is where I'm going to store what's put into via the serial port. So this is where I'm going to store the number you type in. And because it's a character array and I'm reading 1 character at a time, I need some way to manage where I'm at in that loop. That's what this does. And then we define our value like we did before, just like we did before. And then in our setup, it's just like before, except we've added this serial begin, which is very common. We've seen this in previous episodes of this show, where we define the serial port. And I'm going to attach it to pin 9. I kept the same pin number so that it was easy to transition from one product to the other. And then we come down to the loop. This is where things really decide to change. So if you remember the project that we did with Morse code, this is very similar to how that worked. In fact, it's almost identical to how it works. So we define a variable called ch, and this is going to hold our 1 character that we've read in through the serial port. And as we go through the loop, we're going to say, is there any data on the serial port able to be read? And if there is, we're going to come down and we're going to say, okay, the character is equal to, the CH is equal to the one character that's currently waiting to be read. So it's first in, first out. So we're going to read the first character in the buffer, and we're going to print to the screen. It's basically simulates an echo, like if you're typing on a terminal. In the old days with the modems, you typed in AT, you saw the A and the T come back, it was echoing back. So that's basically what I'm doing right here, is echoing back what we typed in. And then I come down, and I'm going to compare this to a number. So if it is a number, which if it's not a number, that means it doesn't make sense to be what I'm looking for input. So if it's a number, I'm going to add to the current array of input the number that I just received, or the character I just received, and I'm going to increase the position by 1. And then I'm going to go back and I'm going to drop out of this and come back to the top, and we're going to read it again. So if there's another character waiting in the buffer, I'm going to do the same thing again. So we do that till we get the number input. And in our case, the highest number you can really enter is 180. I should be putting a check here, and I'm not. And I may actually go add that. In my case, I would pick at 175 just to make sure that it's not going to hurt the servo in any way. Although most of them are fairly intelligent, but you heard mine fighting because I was trying to send it somewhere where it couldn't go, and it would still let me go do it. So anyways, we've gone through this loop a couple times now, and we came up with 120, for example. So 120 is in our array. But the next thing it receives is not a numeric character. So what I'm going to do is I'm going to add a null character to the end of this array, which tells this is where the string ends. So it's 120 null. Null is the end of every C string. And then I'm going to do ATOL, which is converts this string to a long integer, and I'm going to say val is equal to this value. So I've now made it into an integer. And then I'm going to reset my array pointer back to 0, because next time I see a number, I want to start over again at the next number. And I'm going to print to the serial port, servo set to, and then the value, and then I'm going to put a blank line just to clean everything up and make it a little easier to read. So that's what happens in this if statement. Now, here's one thing that happens every time we go through the loop. And this is this right here. The servo needs constant information sent to it. So if you would put this up here in this value, you'd never see the servo move, because it needs to constantly output what it's supposed to be doing. So we put this in this loop, so it's, even if we're not setting a character in, it's constantly sending out things. So every 15 milliseconds, if nothing is being put in the serial port, it's being sent back out to the servo what it should be doing. So this is what the loop does. And this is part of how pulse width modulation, which I'm going to call pulse width modulation because that's probably the better description of how it's functioning, because it's based on the width of the pulse that's going out to the servo. But it needs to constantly see that input. And if it doesn't see that input, it's not going to do anything. So it needs to constantly be told what to do. So we're going to always write this out over and over and over again. Even if we're not changing anything, we still need to keep telling it where it's at. So that is the quick overview of the program. So let's go take it, and we're going to run it again here real quick. We're going to go up, and we're going to do the serial monitor. And I'm back in the mode looking for input. I don't know where I'll last put it, but let's say I'm going to put it at 25. And then I'm going to put a space. You can put anything you want here, as long as it's not a number. Press enter, and you heard it just move the servo. So I can go back to 125. And there's 125. Let's say here's 50. Servo moves to 50. So we're basically controlling the servo and giving it more direction as to where to go rather than just sweep. Now, one thing I mentioned about changing, and to do this, is I want to put a safety in here. And I'm going to do it right here. So I'm going to say that if the value, and in my case I'm going to use 175, is greater than 175, I am going to set the value equal to 175. Let me make this a little prettier. So now let's do this. We're going to compile and upload. And you're going to hear it run back to position 0, because that's what I tell it to do in the very beginning. Up top here where I define the variable value, I say equal to 0. And remember, well, we're not waiting for input to tell the thing what to do. We're constantly telling it what to do. So it basically is going to send out 0. Sorry about all the scrolling. My fingers got stuck here. All right, so then we're going to run. It's running. Let's go out to the serial monitor. And I'm going to say I want to set it to 50. Here, we're in the 50. Let's do 170. There's 170. Let's do 175. Okay, you can barely hear it move. Now let's do 180. Well, 180 space. Servo set to 175. Say 190. Servo set to 175. So I cannot make it do that little jittery thing that was on before in the vibration because it was fighting to get to where I told it to go and it couldn't get there. I've now protected my servo. So a good way of doing this would be at the very top of this routine of the program. First of all, we're going to need to read your instructions with the servo that you get. But you could say, you could do something like this. Equals 175, and down here at the bottom where I compare it to 175, I would just make that equal to max value, just like this. And that way, that variable is easily adjustable at one location at the top of the program, based on your servo. All right, so that is how the program works. So now let's talk a little bit about Pulse Width Modulation. And actually, I think I brought up a web page already. I did right here. And the best way to describe Pulse Width Modulation is like this right here, this little area right here where it says clock. Let me bring this up, make it a little bigger. Is that easy to read? It's not quite. I'll put a link to this in the show notes too. But basically, let's say you have a clock and it's the same frequency up and down all the time. And basically, let's look at this. Down at the bottom it says data is equal to 0. So your pulse width signal is at 0. It's off, basically. So it ends up being 0. In this case, the width of the pulse is this one width that equals a 1. And in this case, it's twice as wide, that equals 2. In this case, it's 4 times as wide, that equals 4. And you can see how the number grows. So the longer the pulse is high, the bigger the number. So that's pulse width modulation. And the servo basically says, how wide is the pulse? Now, there's a bunch of numbers around this that I don't remember where I saw them at, but there is a defined width of the pulse that is measured by servos, and there's like a set standard for it. So basically, this short pulse could be equal to 0, but this longer pulse could be equal to 50, for example. In the case of us, the 0 to 180. Now, the thing that's different about the servos is they look for a particular position inside of this pulse width. So the pulse width, what they're considering here a pulse width, is this width right here. In the case of the servo, it's a lot longer. It's longer than what I could display on this page, much longer than I could display on this page. And a very small piece of it is actually used for the pulse width of the servo read. Now, when I was researching this, the reason this is, and this is something that somebody kind of theorized, but it makes sense, is servos are used for radio-controlled devices like airplanes and helicopters and cars and things like that, where each part of this pulse width, this long pulse width, is reserved for each servo. So if, say, you have 8 servos and you want to control all 8 of them, there's a one big pulse width, but inside that is like a small pulse width. So that's what they call Ppm Pulse Positioning. So it may be that the first 20 microseconds are for the first servo, and then there's a little bit of a break, and then 20 microseconds is for the next servo. And anything like at the 25th microsecond to the 45th microsecond is considered a pulse width. So it would include this data right here that would include the width. So, but the thing about the servo is it doesn't need all these numbers, it only needs one number. So it would start and come high for as long as the number needed to be and drop off, and then you have a delay until the end of the total width of the pulse, with 20 microseconds, for example, I've been using. And then you come to the next servo, and it would pop up again, and for however long the next servo was supposed to be. So I don't remember where I saw that example. Let me see if I can find it real quick. Oops, servo. Okay, well here's kind of an example of the constant pulse width. So they're using milliseconds, and it's much shorter than milliseconds. It's like in the microseconds. But you can see like 1 millisecond means full left, 1.5 milliseconds is center, and 2, for example, was full right. And you can see there's still extra space, and that's because this whole thing runs a lot longer. Let me see if I can find a better example, though. I did find it somewhere. Here's an example of pulse width. So here they're saying 15 to 25 milliseconds, and it's 0.5 milliseconds is full left, and full right is 2.5. So that's actually maybe more accurate, but you gotta remember the whole width of the pulse is 15 to 25 milliseconds, meaning that you can have, 10 servos in that space. So the first 2.5 milliseconds is the first servo, the second 2.5 milliseconds is the next servo, the next 2.5 milliseconds is the next servo. So that's kind of how, that's why they consider it pulse positioning, because you're actually looking at the position in the big pulse to pull out the little pulse, which technically is PWM, pulse width modulation. But for the purposes of the Arduino, it handles all this stuff for you. You don't need to know all this stuff for the Arduino. The library does all this for you. So it makes it very easy. Now I've had to write things before for servos, and I did it on the PIC chip, so I had to learn all this stuff before. It's where I learned pulse width modulation, and that's what they called it whenever I did that. But it was very similar to this, where I had to wait so many microseconds to get into the area where the servo actually was located. And let me see if I can find other examples here. This is another pulse width modulation concept. So basically you see the same type of thing. 1 millisecond is left, 1.5 is center, 2 milliseconds is right. That's 180 degrees. Some servos can go the whole way around and keep going around in a circle. So it's not, they don't all work exactly the same, but they all follow basically the same pulse width modulation. I'm trying to find, there was an example that I saw that gave the full width of the cycle. I don't see it now. But if you go out and look up pulse modulation, what I was showing you with pulse width modulation was at Wikipedia. And they have let me see what they say about pulse position modulation. I did not look that up earlier. Well, it doesn't really give any good definition of it. Let's see. No, it doesn't really describe it in any great detail there either. So I would just recommend you go out and look up pulse width modulation and put the word servo at the end of it, and it'll explain the servo very well. Let me see what it says about servos. It may give me more detail in there. Let's see, servo motor maybe? Yeah, here we're getting into different kinds. So this talks about how servos use the encoders, which, like I said, is for the most part a potentiometer. It's just in a circle. It just tells the thing where it's located. Here they call it, or resistive potentiometers. That's what they call it, the same thing. Which is different than stepper motors, which is, I think, a good another episode with this, because Arduinos use a lot with stepper motors these days, and there's lots of cool things you can do with stepper motors, and a lot of robots and stuff like that. In fact, I'd like to get into motor control a little bit in general with the Arduino, besides the servo, where it takes a little bit more control of it to actually work. But there's a definition of servo. All right, that's pretty much what I wanted to cover tonight. I want to cover the servos, and next week I'm going to try to cover wireless. I messed with a little bit of the wireless, and I was going to do it tonight, but I wasn't quite far enough along with the program to make it make sense for you, probably. And we're going to be working with the Zigbee. And actually, I got a bunch of other things I've got to bring in with me that I wanted to show that we're going to talk about in the future. And I mentioned about a few weeks ago about the on-air light, and I've actually gotten boxes. I got them from Hobby Lobby. They're just like really cheap wood boxes I can paint black and put some stuff in the front to put the on-air sign. I got to figure out how to make the on-air sign, to make it out of plastic and paint it, or what I need to do. I got to figure all that stuff out. But I have all that stuff ready to go. And the one thing I didn't cover that week, which I'm going to need to do with the Arduino as well, is the brightness of LEDs. And if you use LEDs, you probably have figured out you can't really dim them. And actually, typically, if you start dimming them, they actually go bad. They don't like weird voltages. So the way you can dim them, though, is something we just learned, Pulse Width Modulation. And I should probably look that up as well. But basically, you do with Pulse Width Modulation, the longer the pulse, the brighter the LED is. That's how you can do dimmable LEDs. Now, that causes flicker. And if you have ever, like, I know in our studio, the blue light that's lighting up the background behind me are LED lights. They're LED light strip lights, so they can do any color that you want. And but they are dimmable, and if you dim them, they could cause flickering. Now, these don't cause flickering. I don't know how they're doing that. If it's just flickering at the frequency that the camera shutter doesn't see, I'm not quite sure. But I have experienced in the past when they first started coming out with LED par cans, that whatever was lit was sitting there and it was flickered on the camera, and it had to do with shutter speed being almost the same probably as the pulse of the LED for brightness. So that's one of the things that some people complain about backlit LED screens. If your eyes are sensitive to flicker, some people can see the flicker in the LED if you're not running your TV at full brightness. If you run it at full brightness, that's not an issue. But some smart TVs that do the automatic dimming, or you turn the brightness down on even the non-smart TVs, some people can see the flicker. That's why some people have said that they actually have been known to cause seizures for people that have sensitivity to flickering and blinking lights, like strobe lights and stuff like that. So that's something to consider about an LED TV. I can't say I've ever known anybody that had a seizure from looking at them, but that is what they say. Now that they're getting better, like I said, the lights behind me are not flickering on the camera, so the LED lights have been improved. And I don't know if it's because they're changing the frequency of the pulse or what they're doing. It's exactly how they're doing it. I don't know all the answers to that. That's a good question for one of the manufacturers to figure that one out. But we will do an episode on dimming lights, because with the on-air light, I don't want it at full brightness. I got some LED strips that are very bright, and they're way too bright for what I want to do. So I do want to be able to dim them. So it'd be a pulse width modulation example with dimming LEDs as well. So that could be another episode that we do in the future. I am working on some Raspberry Pi stuff right now as well. In fact, the whole thing I did with the on-air, for the on-air light, I may actually go use a Raspberry Pi. And the main reason for that, not because it works great with the Arduino, but the main reason I want to do that is it's very easy to make it wireless and very cheap to make it wireless. Where with the Arduino, the Wi-Fi shields and everything are a little bit more expensive. It makes them really thick, and my boxes aren't quite as thick. But with the Raspberry Pi, I have a tiny little USB Wi-Fi adapter I can plug right into the USB and be on Wi-Fi in no time. And so that's a possibility. I haven't done it yet. I haven't done anything with it as for that, but that's definitely a possibility. I've also, like I said, I wish I would have brought this stuff in with me, gotten a Android stick. It's a little stick that has USB and HDMI on it, and it runs Android. And there are some projects coming up with the Arduino and Android that I would like to do as well for an episode during the week. And I got to play with it, and I don't know if I'm going to use my phone for it or a combination of that. So we may start talking about some possible Android integration with the Arduinos and possibly the Raspberry Pis too. There's a few Raspberry Pi projects that aren't really make it like electronic type make it, but you can turn them into media centers. You can have them do all kinds of neat things now. And maybe it's kind of, we do a couple of episodes with that too. And if that takes off, I may spin off another show just for that kind of stuff instead of more the electronic side of this. But the Raspberry Pi is very cool. I have one running and I log into it all the time. I think it's a regular Unix box, and you can't really tell. I mean, it runs really great. All right, that's it for this week. If you are watching us live, which I don't think you are, well, if you are, there's not many of you tonight, please come and watch us live if you're not. Love to have you every Tuesday night at 7 p.m. You just go to tech-zen.tv and you click on the live link at the very top, and we are live via Ustream. We do record a show and we distribute it in multiple ways. iTunes is probably the most popular way right now. We're getting lots and lots of downloads via iTunes. Love that. And if you do watch via iTunes, I'd really appreciate it if you go out and write some comments about the show. That just helps us bring us up in the ranks at iTunes and helps us get found. I definitely appreciate if you go out and do that for us. That'd be great. If you're watching us on YouTube, please subscribe. There's a button that says subscribe. And if you want to get it automatically, you can get it through many different podcasting. iTunes is just one of them. We're pretty much everywhere. We have a Roku channel now. You can get us on Roku. You have Roku in your living room, watch us live right there on your big screen, right on the Roku. We have a channel out there now on the Roku. And we have more apps and stuff coming as well. We're working on them now. But if you did watch this on YouTube, please click the subscribe button and leave a comment there too. That definitely helps. There's a little button there that says like. That helps us a lot. And if you have a friend that would be interested in it, there's a button that says share right there. Click the share button and share it with your friends. It just helps us get the show word around, and that's what we need to do right now to help build this community. And we definitely appreciate all your help. And I definitely appreciate all the feedback. I've been getting lots and lots of emails, and I love getting emails. And I might not get back to you like within a day or so, but I will get back to you. I do promise I will get back to you on that. So, but definitely appreciate all the contact back and forth. The show is growing good. I just want to keep it going and keep growing it faster, and get it around. And I would love your input on what you want us to do too. I got some input this week on things for future episodes, and they're in my notes, and they will be in consideration for a future show. So we definitely take your input very seriously, and we definitely appreciate your input. And we do have an advertiser this week. Almost forgot. Let me go do that advertisement right now. Wow, do I have something to tell you about today, man? Wow. How many of you guys, you get tired of your cell phone service? I just had an overage. It was horrible because I went and got my data coverage. I went over to my data coverage. And man, it was just beat me up over that. But I have some good news today. I want to tell you about Ting. Ting is the new way of doing cell phone service. And it comes from somebody who's very familiar to almost everybody. You've almost all heard of Two Cows, and that is who runs Ting. And they got some great rates. If you look at the plans, and they're a use what you pay for what you use type of service, where if you don't use the $500 minutes a month that you paid for, $9 for, and you've only used 100 minutes of it, they will drop you down to the next level, which is $3 for the 100 minutes. Would your cell phone service actually take and drop your rate because you didn't use all the minutes that you bought? No. This is the first company I've ever heard. It's a whole new way of doing business. And let's look here. Let's look at some of these rates. 500 minutes a month. If you're using 500 minutes a month, it's $9. So I don't even use close to 500 minutes a month. So I'd be $9 for the phone service. I don't do that many text messages. Let's say I'd be at most 100. So that's $3 a month. And let's say I do a gigabyte a month in data. So that's $24. So my total bill through Ting is $42 a month. And if I don't use that much data, it'll drop the price. And if I use more, it just brings the price up to the next tier. It's all completely automatic, which is awesome. No company has ever done this before that I've ever heard of. They always want to take your money and charge you overage fees. And if you do go over, there's no fee. You just pay for the extra usage that you use for that month. There's no fine for going over and using the service. It doesn't make any sense to be able to fine you for that. So yeah, they have great rates. Plans starting as low as $9 a month, and really $9 a month. That's for 100 minutes a month. So you could get the cheap phone for your kids for emergencies or for your grandparents or whatever. No overage payments. Like I said, there is no more fear. There's no anger, and there's no suspicion or worry about it. You're going to go over that made-up limit that your current provider has given you. And then when you've gone over it, you wait for that heavy bill to come every month, and you're holding it like it's a bomb getting ready to go off before you open it up. And if you don't use it all, like I said, you get credit back. You don't use what you thought you would, they'll drop you down the next tier, and you won't pay that much for that month. And that's revolutionary. There's no carrier I've ever heard of that's done this before. It's awesome. You can put multiple devices on one plan. How many plans did your family have? Most families have 2 to 3 plans, cell phone plans, and they're not like a family plan. With Ting, it's real easy. You add a phone, you just pop it on the plan, and it comes right up. And it starts working right away. And you can actually go out into the dashboard and understand how your family is using the service too. Are they getting close to going over the minutes? Do you want to get a better price for your minutes, go up to the next tier? Do you want to drop certain things down? You can watch how everything's going in nice, easy to understand graphs right on the dashboard. It's great. There is, like I said, there's no fees or limits on usage. So let's say you have a carrier and you have unlimited minutes, and now you've gone over the 2 gigabyte limit, and they're going to start slowing you down. You don't have to worry about that here. There is none of that here. Ting allows you to use all that you want. There is no limitations and no additional fees for that. Tons of free features too. I mean, it does not make any sense these other carriers are charging you for your data. Then they want to charge you to tether your phone. Why? It's your data. You're going to use it after all, right? So it doesn't make sense. With Ting, there is no additional charges. There's free tethering, free hotspotting, free number porting in either direction, in or out. If you want to leave Ting, they'll gladly help you get to the carrier you want to go to. Free picture and video messaging. All that's normal call services, call forwarding, call waiting, voicemail, all that's included in Ting. And get this, there is no contracts. What would you do if you left your current carrier right now? Are you under contract? Would you have to pay a penalty to get out? With Ting, there are no contracts. So you can cancel anytime without any penalty. You can bring your own device or buy one from Ting. They'll work with you however. They're very flexible. You do whatever you want. No problem. And think about this. I mentioned before about the $9 a month. Think about strategically used devices. For example, your mother who doesn't normally use a cell phone and getting up there in years, you want to stick one in the glove box in case she breaks down somewhere. $9 a month. That is great insurance for having your family be able to get in touch. And that's 100 minutes a month. I mean, if you don't use the 100 minutes, it's even less than it. It goes down to 0. So if it's not used, I mean, it's a great way to keep a device around that is easily usable. So yeah, it's great. They bring you can bring your own device, like I said, and they have great devices to buy. They have a lot of devices. Let's go take a look at what we have for the devices. You'll see very modern devices, lots of Android out here. There's Samsung, LG, all the big names are out here. There's more Samsung. There's a Samsung S3, the most popular Android phone in the market, and you can get the S3 in multiple colors and multiple sizes right here in Ting. And you buy the phone and it's your phone. There is no contract to worry about. And for those strategic phones like I was talking about, here are phones that are really cheap, Samsung phones that you can use in the glove box for emergencies. Just keep them charged every once in a while. And I mean, they're really inexpensive. And you can also get your wireless devices for data as well, right from Ting directly. So they have something else that I've never heard of before. And it's the no-hold customer support. Monday through Friday from 8 a.m. to 8 p.m., there is no hold. They turn hold off. So when you call, it rings until somebody picks it up. There is no going into the queue or anything like that. And they pick it up fast, too. And their support staff, they're empowered. They don't have to go to their supervisor to get things. They give you the real name, none of these made-up names. They actually all post in their pictures and everything, and they post to blogs. They're kind of, the way they describe themselves is like you have that person in your family who comes and fixes your computer, your nephew or whatever. They hire people like that already know how to use the phones, and they just train them on the Ting way. It's awesome. I mean, they're already up to speed, super smart, and no hold. There is none of this waiting in the queues and pressing numbers, and it's just immediately ready to a person. They're all empowered to fix your issue. There's those clear, easy to read graphs on the usage on the page, easy to understand bills, cancel anytime, and as you saw on the phones, they are very Android friendly. The operating system that's the most popular operating system right now in the world, Android, and they embrace Android. And their coverage is awesome. You should go to their site and check out their coverage and see what you can get. They use other major carriers to provide the service. So it's not like they're building out their own network. They are already there. There's nothing new to build out. They probably cover you everywhere you go right now, and I definitely recommend you go out and check them out. Now, we have a special offer for you from Ting, from TechZen.tv. You can get $25 off your first bill or $25 off your phone if you buy the phone from Ting. And the way you get that is you go to tech-zen.tv/Ting, and you'll go right to the special page just for us and get $25 off of your first bill or the device that you buy. And that's all just for listening to us. So, and that was something, appreciate Ting supporting us here. And I definitely recommend you go check them out. This is the way of the future, the new way to do cell phone service. That is Ting. And if you've never used Ting, Ting is awesome. I just found out about them not too long ago, and they're incredible. I mean, you go look at the site, it almost seems unreal that they don't have any overage charges or no contracts. Definitely go check them out and go to the link tech-zen.tv/ting, and they'll get you $25 off either your first bill, or if you buy a phone from them, you get $25 off the phone. And that's just because they partnered up with us. All right. I definitely appreciate everybody hanging out. Come back next week, and I think I'm going to do wireless next week. I'm going to do Zigbee. So we'll do a Zigbee project next week. For show notes for this show, contacts, and more, go to the techzen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.